Hi and welcome once again to my channel. Today I want us to look at the transformer or no load phasor diagram, and as you can see I've just plotted the diagram here. So this is a phasor diagram for a transformer or no load. I have IM which is in phase with the flux. This IM is the magnetizing current. Then I have this phi is the flux. Then we have IC, and our IC is the core loss current. And of course, we'll have the core loss current because when you have a transformer operating, we have the flow of current. So that flow of current, of course, will now cause the losses. I have on this side, I have I naught, and this I naught is the no load current that now will be flowing in that transformer. And I'm forming this theta here. So if I just come and extract this triangle here, this one here, I'll have it like this, so that on the adjacent, I'll have IC, and then this is the long side, the hypotenuse, then this is opposite, where I have my IM. And then from there, I can get the value of each component. And as you can see from the Pythagoras theorem, I can get I naught, because the I naught will be equals to square root of IM squared plus the IC squared. That is from the Pythagoras theorem. Then from there, we can get IM and IC. But now you can use the SOHCAHTOA. You can use the SOHCAHTOA term to get IM and the IC. So if I want to get IC, will be equals to, I can, because IC we have the adjacent and I have the hypotenuse, so I can use the term, this one here, that is the cos. So I'll have IC as I naught, then cos theta. That is my IC. Then still I can get IM. IM, you can see M is on the opposite side. Then I have the hypotenuse. So of course I can use sine theta. So IM is equals to I naught, then sine theta. That's what we have. So we can also get something we call the power factor. The power factor of a transformer is equals to cos theta. And from this diagram here, cos theta is equals to IC over I naught. So this cos theta is the same as IC over I naught. That is our power factor of a transformer. Then we have something we call the core losses. We can also get total core losses of a transformer is given by V1, which is the primary voltage, then I naught, the current that will be flowing in the primary from the primary side, then our cos theta. That's what we have. So we know how the parameters from the phasor diagram of a transformer. Then that means if I am given a question that is asking me to get either the core loss current, the magnetizing current, and the power factor, of course, I can use all these parameters to calculate for the unknown. So let us look at an example here. So we are given this example here. A transformer takes a current of 0.8 amperes when its primary is connected to a 240V 50 hertz supply, the secondary being open circuit. If the power absorbed is 72 watts, then we are required to determine the iron loss current, which is now our IC. We also required to determine the power factor on the load, which is our cos theta, or our IC over I naught. We also required to calculate the magnetizing current, which is our IM. That's what we have. So let us look at the solution. So the first thing, we are going to highlight what we are given, and just read the question again as I highlight what I'm given here. So a transformer takes a current of 0.8 amperes. This current that is taken by a transformer is always our I naught. So we have our I naught as 0.8 amperes because we are told the secondary part is open circuit. Then from there is connected, when its primary is connected to a 240V. So this 240 is our V1, is 240V, 50 hertz supply. So the frequency is 50 hertz, like that. And then the secondary being open circuit, if the power absorbed is 72 watts, then we told that the power that is absorbed is 72 watts. Then determine all those parameters. So the first thing, we have seen that the core loss, is given by V1 I naught, then cos theta. That's what we know. So from this relationship, we have the power that is lost as 72. We have V1 and we have V naught. So of course we can get the theta. So we will have the power is 72 watts is equals to V1 is 240, then I naught is times 0.8, then cos theta. That's what we have. Then from there, we can now make cos theta the subject of the formula. So I will divide all through by 240 times 0.8 all over 240 times 0.8, so that all this will become 1. Then now I will have this cos theta as 0.375, and of course we've seen that cos theta is our power factor, so this becomes our power factor. That becomes our power factor. So let us look at the iron loss current, which is IC. So this IC will be equals to I naught cos theta. I have I naught as 0.8. I have cos theta as 0.375. So I just replace here. I have 0.8 times cos theta, which is 0.375. When we work out this one here, this current becomes 0.3 amperes. That is the iron loss current. We can also get IM, and this IM, the IM, that is the magnetizing current, is equals to I naught then sine theta. So we do not have sine theta. We can first use this relationship to get the theta, because from what we've looked at from the phasor diagram, our cos theta was equals to IC over I naught, and IC is 0.3 amperes, I naught is 0.8 amperes. So this is giving us 0.375. And then this is now our cos theta as 0.375. We can get this theta by getting the cos inverse. So this theta is the cos inverse of 0.375, which is equals to 67.98 degrees. That is our theta. So after now obtaining this theta, we can now replace it in this formula and obtain our IM. So IM will be equals to I naught, which is 0.8 sine theta, so times sine 67.98. So when you compute this one, we will have 0.8 times sine 67.98. It is giving us IM as 0.7416 amperes. That's what we have. So that's how we solve the questions pertaining the transformer on no phasor diagram. Thank you for watching, and please, if you are new, subscribe for me. Thank you.